start up the server, and I'll start on the Android side my application too. Let's check here. And if I now click start on my start call on the Android screen, my video is transferred over the local network. Same goes for the cube. Here is the cube. The same goes for the capsule, and we have a connection for every client over the local network, even two on the same machine. So first of all, starting off with a complete fresh project. It's a URP 3D template project with the default settings. Everything is set up for default. So first of all, remove the README assets and import the Unity WebRTC first. So we're here on the docs pages. Go to install package. As you can see, the package manager, add package from Git. And this is the current version. We just copy it and import it. Window, package manager. Click on the plus sign, add package from Git URL. Paste it, click on add, and wait till everything is installed. We don't need the samples here. You can import them if you want to. Maybe we'll have to import them later, but I don't think so. And then start with our project view. Let's create a new folder, call it scripts. And in this folder, we'll just put everything that we'll need. I'll create our main script at first. It's the video chat media stream. If you watch the other videos, I always chose to use a receiver and a sender script in the previous examples. Not in this case. In this case, we'll just use one script for sender and receiver, and I'll show you afterwards how everything is done. So let's set up everything first. The next thing will be our signaling message. Let's create a new SIGAP script, signaling message for video chat, and we need a video chat WebSocket server for signaling processes. A video chat media channel service, video chat media, let's call it stream service. This will be our service that will take care of all the signaling process in cooperation with the web server, WebSocket server. A simple rotation script, and that's it. That should work out. And for WebSocket server, we still need our WebSocket for C#. So on the repo for WebSocket sharp, download the project. You can build it using Visual Studio and then copy the WebSocket sharp DLL. I've shown how it's done before, but just to give you a small glimpse of how this is done. I already downloaded the project and I open Visual. Binary, debug, and there is our library. Just open the folder in the Explorer, copy the DLL, and paste it in our plugins folder. Here we are. And now we're basically finished with all the setup, and we can go forward to our main application. We'll leave the camera here. We'll create a new camera and call it streaming camera. And this streaming camera will basically do everything for us regarding the streaming. We can just leave it like this. And we're creating a WebSocket server. Let's call it WebRTC dash WebSocket dash server. Another object for WebRTC dash VideoChat client, and another one for WebRTC dash VideoChat. Let's call it receivers. This will be our signaling server, our client for sending and receiving the data, and this will display the video feed from the other clients. First of all, let's start with the simple stuff, the signaling message. And again, if you've watched the other videos, this will look very familiar for you. Yes, I missed the signaling message type. Let's create it here. Signaling message type, which is basically just an enum helping us differentiate the different signaling messages. So here's the signal message type, the signaling message, just clean that up. And let's set up the simple rotation script. As always, if you want to better code, feel free to pause the video and just type it. On the other hand, I'll try to offer you the source code as soon as possible via the YouTube channel membership, and maybe this is a good part in the video to tell you about the upcoming memberships or the supers that I recently enabled on my YouTube channel. So if you're a fan of my work and if you want to contribute and help the channel grow, and in case, even if you're interested in the full source code project, even from the videos I recorded before regarding WebRTC, feel free to become a member and get access for that. I'll enable that very soon, so stay tuned and check out the channel regularly. But let's continue with the implementation. So we'll just set up the WebSocket server first. A WebSocket server, my own IP address, port 8080 to keep it simple. And on the way, I'm just trying to get my IP address, have my port specified, starting a WebSocket server with this service. Start it, and on destroy, I'll stop it. And for the service goes the same. We're just creating a new WebSocket behavior. And now there is something in here that will be very important soon. So we'll have a number of connections, and the naming convention for these connections is the first number is always the sending client, the ID of the sending client, and the second number is always the ID of the receiving client. You can, of course, come up with your own naming convention or do the handling and the signaling on a different way. But for me, I thought that this is very intuitive and easy to handle even for larger networks, and to see at once from where to where this connection will lead. Because in this case, we're going to create a peer-to-peer connection for every peer-to-peer one sending and one receiving connection. And the connection counter does what its name says. It counts the connections, and the number of this, whenever possible, will be the ID. So if the connection count is 0, the ID from the sending client is 0. If it's 1, then it's 1 and 2 and so on. So this is the setup for 3 clients. And every time we open our WebSocket connection, I first of all send my client ID, in this case, the first case is 0, to the client who connected, and send all the connections that are planned here, this one. So I know that my WebSocket application will have a maximum number of users. In this case, it's 3 users. You can think of it like a network room, and all the variations of connections that are possible are in here. So just to keep it simple, these are for 3 clients, client 0, 1, and 2. And every user will have to know about every connections. We'll filter them out later. I just send it here. You can already filter them out here, because when I'm on client 0, I will connect myself to 1 and 2. And the connections that are not regarding me, like 1, 2, or 2, 1, it usually be filtered out at this moment, but we'll do it later on. So don't be afraid. Don't be worried. It's coming soon. And here on the on message, every time we're sending a message, we're just forwarding our message to everyone except ourselves. And the clients themselves will take care if this message is relevant for them or not. So let's go on to the VideoChat media stream. That is basically our main script from everything that's coming. And we'll just start simple. For heading over to the VideoChat media stream script, we'll just need the session description script, the candidate init script, and the iJSON object interface. First of all, let's create this one. This is already familiar. We have an interface for converting objects to JSON and from JSON. The candidate init script is for handling the candidate data and for sending it over the network. And the session description script does the same, converting everything to JSON and sending it over the network. And for the VideoChat media stream, we'll just start off very simple. So first of all, we have a client ID. This will be set via our web service. This one will set the client ID when I connect. The camera stream will be a link to our streaming camera, and the raw image will display our current camera feed. This one. And there's a collection of receive images, which will be used for holding all the images that receive the video data. The dictionary will hold all of our connections, all of our peer connections identified by the ID. The video stream track will hold our own stream, camera stream, and all the received offer variables, like the has received offer. The session description and the channel ID will help us receiving the offer and creating an answer for that. The WebSocket will take care of our connection to the server, and the image counter will just count up the received images as each client has 2 receiving images. Every time the next client connects, it will just count one up and display the received stream to the next image. Sounds complicated, it's actually pretty easy. So first of all, we will init our client and start. On update, we'll just check if we have received an offer and create the corresponding answer for that. On destroy, we'll just stop our own video stream, close every connection, the RTPC peer connection that is open, and close our WebSocket connection. And now we're getting to the interesting part, defining a port, connecting to the server, do something on message, we'll implement it in a second. We connect to the WebSocket server, we'll capture camera stream and display it in our source image. Tell WebRTC to start its own update project. And later on, for creating peer connections, first of all the peer connections that this client will handle with a create peer connection method with an ID. This ID will be our client ID, channel ID, connection ID, whatever you want to call it. It's more like the connection ID. And this ID is the same as we had in the service, like this. So this is our ID here. We're creating a new peer connection on IC. The candidate will just exchange the candidate messages here with the ID. Connection change, we just log the connection change. On a negotiation needed is called as soon as we add a track to a connection. So we will need that to create an offer for later on receiving an answer, for creating overall RTC connection. And the on track is called on the receiving end for checking if the received track is a video stream track, and if there is video received, just display this received video on this texture, receive the counter, so as the next track is received, the next image will be used for displaying. And then return the peer connection. The next method is basically the same as we had it in the other videos, like creating an offer for a connection with a certain ID. You already know that. I won't explain it here again. So if you're curious, check out the videos before. They're on my channel and linked in the description box or at the end of the video. And we're sending an offer here. And after we received an offer, our client has to create an answer for a connection with an ID. Same thing here, the handling of the RTC connection, WebRTC connection, and sending the answer message over the WebSocket. Something that we hadn't before was the call method. This is just for establishing the connection. So for every connection that will go out, so that will be used for sending, the first number is the client ID. Like in this case, my client ID, for instance, is 0. If the key, the first character of the key is the same as my client ID, this will be a sending connection. So for instance, if we have client 0, the connection with ID 01 and 02 will be our sending connections, and therefore we'll have to add a track with the current video stream that we record with our camera will be sent over the network. That's the basic for our class. So the part that it's missing now is this one here. And this part will now handle receiving data. The data will be converted to a signaling message from our own type. This signaling message is a type. So if we check out the signaling message, it's a message array where I split my string by the exclamation mark, and this is the default. And if everything goes right, we will have something like this, a valid signaling message, or something that it's not valid, so it's only forwarded like this here. If the signaling message is an offer. So we're trying to establish a connection. We're sending an offer to the others. So only clients which are bound to receive data from this certain sender will accept this offer. This one here. The client ID is the second part of the channel ID. So when I'm on channel 0, on client 0, every channel where the second character is a 0 will accept this offer. Let's check our service. I'm sending on this connection and this connection because I'm client 0, and the connections who will accept my offer will be this one because the second character is 0, and this one because the second character is 0. These clients will receive the offer, prepare everything, the channel ID, from where is this coming, how is my session description, and set the has received offer to true. And in the update method, this client will now create the answer for this channel ID, received offer channel ID, and creating the answer. And as we saw beforehand, we'll now create an answer with a certain ID and send it back to the sender. If I'm now on the sender side, a second, here it is, I'll check if the answer that I got will match my ID. The first digit, the first letter, the first character of the channel ID sending this answer message must match my client ID. So we're now going jolly round. I sent from 01 to 10. This comes back, and if my client ID matches 0 again, I will receive the answer. Sending here, coming back here. The same goes for 02. Sending here, getting an answer for here. If that matches, I will create the answer, set my session description, and set the remote description for this specific connection, which is stored in the PCs dictionary, which is the peer connections. And that's basically everything you need for setting up the connection. And the next step is exchanging the candidate data. And this goes basically the same way. So as we saw beforehand, the RTC peer connection has an onIceCandidate method, which will generate the candidate data and send it over the network with our ID, the channel ID. And after this is sent, every client receiving the message will check, okay, am I the client who should receive this message when the second character of my channel ID matches my client ID? In this case, again here, the second character, for instance, is 0. If that's the case, then on client 0, I will receive the client data, the candidate data, for instance, sent from the connection 10. Other way around, the same. So client 1 will receive candidate data sent from, for instance, 01. Receiving the candidate data, setting the candidate, add the ICE candidate to this specific connection, and everything is fine. That's basically the WebRTC signaling process. And something that you may have already guessed is, if I'm sending the first messages here with the client ID and the connections, I'll just check, okay, if it's not some predefined signaling message type, it's basically something that I have set up for signaling the client ID and the connections. You can do it in your own way or just extend the signal messaging type. If the data contains a pipe, these are the connections. So all the connections, this is basically the second message. So let's start with the first one, it's the client ID. If it doesn't contain any pipes, I'll grab the client ID and I'll set the client ID to the data. On the other hand, the second message, if I'm sending the connections, and this is the pipe that will be used to join our connections to a single string. For each ID in the string, I'll create a new connection if the connection contains my own client ID. So if I am client 0, I will add all connections containing 0, like 0, 1, 0, 2, 1, 0, and 2, 0. I have an example here in the comments as well for client 1, for sending 1, 0, 1, 2, and for receiving 0, 1, and 2, 1. And after this all is set up, our connection is able to handle multiple clients. But before we can do that, we have to set up a little bit more of our project, which we will do now. First of all, we will set up the server, WebSocket server, set up the client, VideoChat media stream, and connect our streaming camera here. We don't have a raw image yet, but we can check where our streaming camera is. It's over here, and there is the main camera. The main camera will be at 0, and the streaming camera will be at -10. And this streaming camera has a child, like a cube. This will be 5 in front. Let's check. Yeah, The cube will have the simple rotation on it so that it rotates. And all we have to do now is adding the UI. So we're adding UI canvas. Here, screen space overlay will do. And we'll just need a raw image UI. Raw image with a width of 2 like this. I guess we'll just have to make it a little bit smaller. Well, I don't care, just changing the scale. This will our receiving image, no, our source image, our sender image, displaying everything that our camera sees. Just move it over here. Minus 600, which a little bit up. Minus 300, only 300, like this. And then we need a button and import text mesh pro essentials. Yes, sure, that. And this button will be used to call the connection. Minus 200. The text will just tell us to start call. Adding an on-click method here from the client call. And of course, we need the receiving images. Just duplicate this one. Call it receiver image. And we have 3 clients, so we have to duplicate it. And here we have the sender image, and the receive images should be 2 images, not 3. Remove that. Add our 2 raw images here. And that's our first client. We will need a second client too. And a second streaming camera with something that will rotate. Just create a new video object and call it capsule. Move it up here, delete the cube and the capsule, adding this simple rotation script here. And moving all of that 10 to the sides. Do it 20 and move this one also 10. Let's see. This is the main camera, streaming camera, streaming camera. And the UI has perfect. First of all, we noticed this, that our camera images will be different when having multiple cameras in the scene. To prevent that, we'll have to change the priority of the cameras to a value that will allow us to render our main camera, which will be basically our UI camera first, and the streaming camera will get priority -1. The second streaming camera, the same, -1. If we now activate them, UI camera 0. No, okay, now it's correct, sorry. Misclick on my side. And we'll just, I guess, parenting, this one will do. Now we're having our streaming camera 1 with a cube in front, streaming camera 2 with a capsule in front which will be rotating. And our client will have the streaming camera 1, the client, well, the numbering is not correct, 0, 1, and there will be a receiver image for that too, so we'll just add, I guess, a few more. First of all, let's put them down here, like this, like minus 200, then make them smaller, like 400 and 225. Something like this, pull it over here. Do the same for that. What was the values? Minus 200. Make it 400. 125 and minus 500. So that's the first. Let's make the panel UI panel and parent everything for the first receiver here. I guess we can just make it transparent, duplicate it, and then move everything on this side, plus 600, plus 200, plus 800, plus 500. I guess we'll just move them up a little bit afterwards. For multiple clients, this should be enough for 2. And the start method here, we'll have to use the other client for calling. So I guess we'll just try if it's working. Start it on. The first camera is already rendering. Okay, the audio listens are not fitting, and the start call was okay. So there is something going on here. Is the stream camera, the sender image is wrong because we need this one, the receiver image, and the panel. We have to remove the background from the panel, otherwise we're not able to click anything. We'll just change this naming to weapon, not WE. So I basically created the receivers for this. You can just omit it. Let's start it on again. We have 2 camera images, one with the cube, one with the capsule. Click on start call. Cannot click the start call. Why? First of all, let's deactivate the audio listeners from the streaming camera. And then let's check why we're not able to click in here. And just remove this one. This one, no image here. Let's see. Yeah, now it's working. So start call with our cube. You're receiving this one. This one, okay, that's the wrong images here because we have this two here. We need this one and this one. You can play around with the naming because this may get very confusing. And we just call this receiver handler 1, receiver handler 2. And now it should basically work. So we're starting the app. Mono behavior using the new keyword, signaling message, video chat, media streaming. Just give me a second. This is not because the signaling message is not a mono behavior, not at all. We don't have to use this one. It is simple C# class. Okay, let's call it the receiving canvas, the receiver canvas. Save it and let it, and now it should work. Okay, two camera images, start call. Our cube is displayed here because that's the capsule side. The capsule is displayed here because that's the cube side. If there would be now a third client, this would be the images for the third client. We'll just switch it up a little bit because we can use the image here and this one here. We're just duplicating client and the receiver panel, moving these two up to around 0, these two to around 0, 2, and the receiver itself for the third client. We'll just take this, move it down here around minus 300, and having the two receiver images here. I guess we can just move it farther down, like minus 350, and moving this one up, plus 350, moving the images up 100. Same for the first 350 and 100. So 3 clients now. The third one will have its images a little bit further up, minus 100. Okay, that looks already pretty good. And this client should have the right images here and here. So let's see. Oh yeah, there's no camera for the third one. Streaming camera, duplicate all the 3D objects. I don't know. Let's take a cylinder with the simple rotation script and make it, I don't know, to make it a little bit bigger. Going with the streaming camera to 30 to just have everything under control. And for the third client, setting the streaming camera right, and the sender image needs to be right too. Here we go. It's something like this, just to make it a little bit better recognizable. And the button, of course, to have the right call statement too. Yeah, okay, that's Just go with it like this. It's a little bit confusing, but it's not that bad. So if we're now starting the app, you see that there is a client with ID 2, 1, and 0. And if I'm starting the call, the other two clients will receive the cube. If this will start the call, there's one receiving the capsule, and the other one who has no receiving connected will receive the capsule stream 2. And starting the call here will result in a preview of my own camera and preview of all the receiving streams. And you can go with that even further for receiving more than 3 by just duplicating the VideoChat media stream script, fixing up the references, have something to receive, and you can do that over network too. So just to give you a short impression of how this may look, I'm just keeping my server here, 1, 2 client here, and everything where there is a 2 will go on to the Android client. So we'll just be moving this one, and let's see. Let's just switch to Android quick. Change to portrait mode. Ah, yes, okay. So we'll have to move the receiver panel to the center, or everything is receiving the third part can be moved to the center. Okay, this doesn't work like this. Let's just move it like this to 0. The button can be moved to 0 as well. Just a little bit less in the up. And these two minus 100, 200. Yep, and this will with 100. Well, it's not beautiful, but it will work. And now we're going to deploy it to our Android phone, so I can show you that this works over the network too. Here we cannot deploy it because we haven't changed our settings for Android in the other settings. While being in the settings, make sure to select OpenGLES as the graphics API for Android, as this is the only one which will work. Can use IL to CPP, this is okay. This one, just make sure to build it for RM64. Change that. And change even the name to WebRTC test. That doesn't matter at all. And that's it. So after the build is succeeded, we'll just switch everything back like this. Go to landscape again. Enabling this to this. Disabling the streaming camera, disabling the first 2 streaming cameras. Disabling this because this is on Android, and disabling these two. So we have 2. Oops, wrong landscape, this one. We have 2 clients on our PC, and the third client is on our Android phone. Important to know is that you have to connect all the clients first before you can start the calls and establish the connections, just to make sure that everyone is, let's say, in the room before start chatting. So let's play our application, and just as a notice, go to edit project setting, sit under standalone, run in background. Here we go. This is the setting I've been looking for, so everything can run in background, and I'll start on the Android side my application too. Let's check here. And if I now click start on my start call on the Android screen, my video is transferred over the local network. Same goes for the cube. Here is the cube. The same goes for the capsule, and we have a connection for every client over the local network, even two on the same machine. So yeah, that's it. I hope you liked the tutorial. If you want to have access to the code, as I said before, just check out the community tab for the supers and the channel members. I will come up with something within the next days or within the next week. Stay tuned. And if you like the video, feel free to like and subscribe. You know how this thing works, and I'll see you in the next video. Bye.